right, well, I am here with Eric from BCN. Can you introduce yourself, Eric?
Sure, Dave. So thanks, first of all, for inviting me to this podcast. So I'm Eric Pallarés. I'm co-founder and CTO of BCN3D. And I'm in the 3D printing industry since 2012, when I joined the project that lately became BCN3D. At that age, I was just an industrial engineering student. I was looking for a professional challenge to start applying what I learned in the university. And yeah, I found out that a technological center pretty close to the university was using 3D printing, both for industrial and even for you know end customers, enthusiasts, hobbyists. And I fell in love with 3D printing. So here I am, 9 years later, enjoying the growth of the industry.
Yeah, that's pretty cool. My understanding is that you and some of the other co-founders started BCN as a university project. Like, how did you guys come up with the idea of even using 3D printing at all 9-10 years ago?
Yeah, well, the technological center depends on the Technical University of Catalonia here in Barcelona, and actually is one of the main technological centers in Southern Europe, working with additive manufacturing. Actually, here in Spain, it was the first center owning a 3D printer, industrial 3D printer back in the 90s. So the technological center had pretty long experience back in 2012, providing services to the automotive industry and other industries that are pretty strong here in Catalonia. But of course, the customers were industrial. They had in the technological center SLA and SLS machines from 3D Systems mainly, and they were providing those services. And then a student that was doing an internship at the technological center during summer internship. It was a guy from Portugal. Came up with the RepRap project and say, hey guys, do you know that there's a do-it-yourself project around the world, open source? You can build a printer capable to print
Look,
other
we can make
printers.
one.
Yeah, and we have 3D printers, industrial 3D printers, so we can make the very first RepRap machine here. And yeah, the management of the technological center said, okay, go ahead, it's your internship, feel free to play around. And yeah, a couple of months later, Xavi, the CEO, currently the CEO of BCN3D, started a little business unit inside of the technological center and said, okay, let's build kits for end customers willing to explore this amazing new technology that we have discovered. And we shortly realized that the industrial customers coming from automotive companies stopped by and were staring at the desktop printers and saying, look, I've been using 3D printing as a service for many years, but now finally I understand how it works. Mm-hmm. So this is how it started. We realized that there were potential on that technology, and that the people that was already using 3D printing would embrace a more affordable technology instead of using outsourcing services for additive manufacturing. So that's how everything started in 2012, and yeah, pretty excited about the growth of the industry, as I said before.
Yeah, and 2012 is kind of where things really started to get rolling. Yeah. With, like the RepRap project actually became a mature thing. Certainly in 2012, there were other technically minded people kind of thinking the same thing around 3D printing. I mean, 2012, 2013, that's right when MatterHackers began its existence as well, in more of a software and materials at the time. But such a cool time, and so many revolutions happening in this space.
Definitely.
That were a result of many young folks in the university just sort of nerding out, which is cool.
Yeah, we had the lack of having freedom to play around. We started building the printer models from the community, from the open source community. But then we were engineers or almost engineers pursuing our engineering degree. So we started developing our own models based on the I don't know, the Mendel Max and the Prusa I2. So that's how the very first BCN3D printer was developed in later 2012.
Yeah, that's awesome. What was, early aspirational engineers, I guess we'll describe your founding team. What was your secret sauce? Like what niche in the market, or what did you guys bring to the table that really made you BCN unique?
Yeah, I would say that we had a close relationship with customers that were using industrial 3D printing. So that allowed us to rapidly shift our focus towards professional users rather than hobbyists. In 2013, there was not many Chinese competitors or low cost kits, but the things started to change quickly, and at that moment we were already thinking about providing solutions to the professional customers. For example, with the SLA and SLS machines, we saw the potential of printing with freedom of geometry, complex geometries. SLS, of course, with without the needs of printing supports, and SLA with all the complex tree-like support structures. And we realized that with FFF, there was a huge limitation with all the support structures that were super complex to remove. So in 2013, we developed an upgrade for our kit printer that was a dual extruder that was assembled on the same carriage, and that was our very first experiment with dual extrusion at that moment. Because we realized that printing with a different material, the supports, was very convenient compared to printing with the same material. And yeah, I think that thinking on the professional applications of desktop 3D printing, but doing an effort to make it affordable, is our secret sauce. So we try to keep this approach over the years, always releasing, of course, every time more advanced solutions, but always with the affordability in mind and the ease of use and the versatility.
Yeah, and I think you're describing a point in time where at least BCN came onto my radar. I think I saw even some social media images of some complex dual extrusions that were either very functional, and I was jealous of the support structures that you guys were creating, or were really beautiful, and dual extrusion sort of using two colors to make really unique and cool models. For the time, it was kind of in the sort of the desktop market. That was before it was happening. And so you guys saw the value of your most technical, high value customers needing more technical solutions that required dual extrusion. For someone who doesn't know what dual extrusion is, maybe what is dual extrusion? What are its advantages, and how come you found that and identified that as like a key point of what you guys were going to tackle?
Yeah, well, of course, if you want to print a model, you need an extruder. It's the subsystem responsible for pushing the filament, melting it down, and extruding it to create the model that you want to get. But of course, depending on the geometry, sometimes you need to build support structures in order to avoid the material to collapse due to the gravity when you are applying new material layer by layer.
Can't stop it.
Sure. So at that time, 2012, almost all the printers were building the support structures with the same material than the final model. The problem is the material is the same, so there's a strong bonding between the supports and the model, so it's hard to remove by hand, or you need to spend a lot of time. There's a huge risk to damage the part, to break it, depending on the small details of the part. So it's not very convenient, that post-processing step. Industrial 3D printers, Stratasys at that time and others were using a different strategy that was using a different material to build the support structures. Because of the different addition force between both materials, it was much easier to remove the supports, or even those support materials could be removed with, water or chemical solutions. So it was possible to completely automate the post-processing, just rinsing the part with the supports in a solution, and after a few hours, taking the part free of supports. So dual extrusion is having two different extruding subsystems to push different kinds of materials, or in any case, two different filaments to build a single part.
Nice. And what, there's many methods of going about dual extrusion. Which one did you guys find?
Yeah, well, the very first solution that we developed and as an upgrade kit was quite similar to the other solutions in the market at that time. It was a big extrusion system, mirrored and put all together in the same carriage. So it worked. Of course, it was able to push filaments alternatively each layer to build both the support structures and the final part. But the problem was that the carriage was very heavy. There was twice the weight, the mass needed to print. So in terms of inertia, moving masses is not good for the final surface of the final part. Also, it was hard to calibrate because it's super important for dual extrusion to make sure that the relative distance between the tips of the nozzles are perfectly calibrated. So when you change from one extruder to the other, you are printing exactly in the same spot. So, calibrating those hot ends with a simultaneous dual extrusion assembled everything in the same carriage was not very convenient. Also, the material is molten inside of the hot end. So due to the gravity, again, you cannot avoid some... gravity again. You cannot avoid the material dripping. The molten material tends to drip out of the nozzle. So there's cross-contamination. So there was a lot of drawbacks that make the dual extrusion that we first introduced not very convenient, or at least not very useful for the users with little experience with 3D printing. Mm-hmm. So we thought it has to be some way to do it better, easier, faster, more convenient for the end customer. And that's how we came up with the IDEX, the IDEX architecture.
Yeah, I think IDEX is unique. And when I think of BCN, the hardware that you guys have out today, even, I think of IDEX. I think it's a staple that BCN has really rode with, and I think you guys have really succeeded with it. Again, to just pull back, what does IDEX mean, and how does that system have advantages over any, the single carriage system?
Yeah, so IDEX stands for Independent Dual Extruder. So instead of having both extruders or both extruding subsystems in the same carriage, you split the both subsystems in two different carriages. So when you are using one material, the other extruder is parked aside, so there's no material dripping, there are less inertias, and also it's easier to calibrate because it's easier to access to it's easier to do it by software rather than having it the same carriage. I want to make clear that BCN3D was not the inventor of IDEX. We registered the trademark, but we, at that moment, we are still part of an open source global community. And at that moment, we were very, we had a strong involvement in the open source community. And we saw a video on YouTube of a user. Mm-hmm. Actually, if you Google book about 3D printer, you will find the video that inspired us back in 2013 to develop the IDEX. We saw that a guy built a RepRap machine with this concept of two different X-axis dual X carriages, splitting the both extruders into independent devices, and we quickly realized that was the best way to do it. So we, inspired by that solution, we started working how to make that possible beyond a prototype, how to make it reliable, consistent over time, how to make it as cheap as possible, because of course you are adding more hardware. So it's going against the cost of the final printer, but overall we are pretty happy with how everything was designed and how with the solution we came up with.
Yeah, I think you guys came to the table with something that was elegant and marketable. And I think it was something that you said kind of subtly, but it's really important. Getting dual extrusion to have the nozzle tips know that two nozzle tips have the same zero relative height compared to, you know, the bed plate or the part. That's really hard to mechanically do, and there are many systems that do succeed with either lifting it or putting it up and down. But when you make those independent, then you can come in essentially with one independent 3D printer that has a Z height, a nominal Z height that's calibrated, and then another one that has, they don't need to be the same height. Instead, as you mentioned, you can fix it in software or in the firmware. And that to me is a huge advantage of IDEX to be able to do that.
So yeah, I mean, I think it's important to remark that idea. I mean, it's great to have good ideas, but sometimes it's very difficult to bring that ideas into something feasible and repeatable over time. So we are doing IDEX 3D printers for 7 years already. We are in the way to master this art because of course there's always room for improvement. But yeah, I think definitely is what IDEX is what put BCN3D on the 3D printing map, because at that moment we were a group of students. Well, not I was already an engineer at that moment, but yeah, a bunch of students or junior engineers, and with that innovation is what was possible to create a distribution network, to have you guys involved with us and establishing that reputation in the market.
Yep, no, that's great. Like I said, I think you guys made a great sort of stamp of the name IDEX, and although it existed, bringing it to market, because it existed on hobbyists, garages and YouTube, but the first product that I was aware of anyhow was the BCN early hardware from BCN. Outside of being able to do dual extrusion in two different materials, does IDEX have any other advantages to your customers?
Yes, definitely. It have a huge advantage in terms of productivity. So when we first introduced the IDEX architecture in the Sigma 3D printer back in 2014, we were very focused on prototyping. So at that moment, 3D printing was used mainly for design validation, visual prototypes, and support structures were very important to get that complex parts printed with good surface quality. But as the time advanced, we started to detect a new trend that was growing. That was people were using 3D printers to print final parts.
Yep.
So thanks to the IDEX, we are like having two printers in one, because we can print simultaneously with both tool heads. So this is something huge for us, and actually today, 1 out of 4 print jobs approximately are using this feature of printing with both tool heads at the same time. So
wow.
Yeah, this is like having two printers in one, because in the same time you get two parts.
Yep. And the advantage there is that you have the carriages and the z-axis already moving in the right direction. So having the x independent, you can then print two at once.
Yeah, right.
And
so we can print, we can duplicate the same part, or we can print the mirror version of that part. So for symmetric applications, I know with healthcare or automotive, it's quite convenient. Or if you want just to print the same part multiple times, you can duplicate the printing job.
So someone doing batch printing could print two of the same part in the exact same time as any other printer could print one part. And in an automotive application, when you have a left-hand mirror and a right-hand mirror on a car, you can print both of those at the same time because their Y and their Z movements are synchronized.
Yes, that's right.
That's fascinating.
So it's mirrored on the x-axis, correct?
Yeah. Yeah. That is very cool. Very cool. BCN's this tiny little university startup company. Generally, where'd you go from there?
Well, we started to grow. We established a distribution network thanks to the Sigma that was taking profit of the IDEX architecture. Then we upgraded the Sigma, introducing some improvements that a lot of feedback collected from the community and from our customers allowed us to improve the product. Then we released the Sigmax, which was like doubling the x-axis, and to take profit of the mirror and duplication printing modes was much more convenient. So the business unit inside of the technological center continued to grow until the moment that it made no sense to stay inside of the university anymore. The technological center was a non-profit organization, so they were keen on spreading the technology inside of the society, while the BCN3D project was trying to develop new technology to solve end customers' problems, and to do that it needed money. So it was not really compatible at that moment, the mission of the technological center and the needs of the project. So in 2019 we did a spin-off from the university. BCN3D became an independent company, and we received some funding to keep the business growing, and to make the team grow as well, to develop new products, and to kick off new R&D projects, and making all the marketing, sales activities so important to compete in this growing industry that is it's very populated at the moment. But we're pretty comfortable with our position. Of course, there's a lot of things to do, but I think that BCN3D is recognized as a brand, and in part is because of that innovation of the IDEX. But we don't want to live forever because of the IDEX. We need to do more things. So that's what we are doing in the R&D lab.
Very cool. And what are your current products? Like what sorts of things would people be looking for in the products that you guys currently have on your line?
Yeah, in 2019, we realized that there was kind of a gap in the market, because in terms of professional desktop 3D printers, it was a segment of the market very populated by you can get printers from below $1,000 until $6,000. There's a lot of options, but then there's a gap until reaching maybe $20,000 more or less for more industrial solutions.
Yep.
So that's why in 2019 we released the Epsilon line, which was intended not to cover the desktop segment of the market, but to cover what we are calling Workbench, which is something in between the desktop and the industrial. So it's a solution, a printer line focusing on technical materials to satisfy the customer's needs of printing big parts with technical materials beyond PLA, with repeatability, with consistency. So during the last year and a half more or less, we have been pushing a lot this concept of Workbench 3D printers, providing a complete solution, not only on the printing process, but also in how to store the materials, how to keep everything in the right conditions. So over and over, you can expect the same results with the BCN 3D printers.
Yeah. So you're referring to like the smart cabinet that recently launched. Cool.
Yeah.
Nice. What kind? So you started off with kind of more tech companies and people trying to push the boundaries. Who are your current customers? Like, who's your current like target customer, and are there any specific use cases that you think are interesting?
Yeah, I would say that nowadays engineering, automotive, and manufacturing our main verticals. Recently, last week, we released a super cool use case with Nissan here at the assembly line they have in Barcelona. So since 2014 actually, from the very beginning of BCN3D, they are using our products to build figs, jigsters, jigs for the assembly line, and they have I think they have printed more than 700 jigs over these years, and they are using constantly, day after day. They have built thousands of cars using those printed jigs. So this is a super cool application. Maybe it's not so fancy as saying, oh, Bugatti prints a brake caliper using metal 3D printing. It's okay, but I mean Nissan is assembling hundreds of cars every day using 3D printed jigs with BCN 3D printers. So this is super cool.
Yeah, that's awesome. I think that's a really cool place where the market is today, where you can see the adoption of, as you said, not Bugatti putting in final functional parts sending off as brake rotors or something, but instead these like high utility sort of manufacturing instruments that aid the process of creating and making more efficient those cars coming off the line. That's really cool to hear.
Yeah. So manufacturing. I mean, all sorts of companies that assemble any kind of product are users of BCN 3D printers at the moment. With the Epsilon line, the Workbench 3D printer line, we see a lot of people using 3D printing for final validation. End use parts or working prototypes that are put under the working conditions that the final part may be injected or manufactured with other technologies will be used. So we are taking profit of the ability of printing with ABS or fiber filled materials. So for functional validation, it's very, very convenient, specifically in the engineering fields or automotive fields.
Yeah, that's awesome. What are you excited about next within the 3D printing industry? Could be your products or something else.
Well, I think that there's we need to look at the bigger picture. 3D printing is growing so fast. I mean, if you tell me 5 years ago that we are able to print 300 millimeters long parts with carbon filled materials, I would say you're crazy. That's impossible. But we are advancing so fast. But as I said before, I think what we need to look broader and see that 3D printing is one of the pillars of Industry 4.0. So we need to integrate on that industrial revolution. And there is a lot of things to do in terms of software integration. And it's not necessary to think in super fancy technologies like AI or like that. I mean, of course, there's a lot of things to do, but integrating these solutions inside of the customers' systems, enterprise systems, it's something that in the coming 2 or 3 years will change a lot. So I'm super excited in seeing how the 3D printing solutions that we are providing are not isolated in a manufacturing lab, but are part of the value chain of an automotive or a healthcare company.
Yeah, I think that's an important thing to understand, and at least the way sort of I digest what you just said is 3D printing small. Like it remains a very small portion of how the world works, and I think there's a lot to be learned there. Even previously, I think BCN did a great job working through a global pandemic to try to fill the manufacturing gaps. At least locally you guys were printing a lot of PPE, right?
Yeah, that's right. So when all the pandemic started here in Spain, well, together with the rest of the world, here in Europe, we had a terrible shortage of PPEs. So yeah, a lot of around the world, everybody with a 3D printer started joining the cause and printing face shields, masks, whatever, respirators, and we have a 3D printing farm with more than 80 or 90 printers. So we put those printers to work 24/7.
Yep.
We delivered thousands of PPEs, and I think that's a social proof of 3D printing is useful for the society. I mean, the people that like us are in the industry for several years. That's obvious, but I think there's been a recognition of that utility, and this is good. I mean, of course, it's been super sad situation, all the pandemic thing, but it's been positive for the 3D printing industry because people understand that 3D printing is not just printing Pokemons, which is pretty cool. I love printing Pokemons, but we can do useful things beyond putting a nice figurine in our desk.
Yeah, I think 3D printing was able to fill the gap that traditional manufacturing left. Like something's needed somewhere today. Spinning up molds takes some time. Getting the CNC mill all calibrated and spitting out parts takes some time. 3D printers, you get a file, you distribute it around the world. You can have one, a couple hundred in every city within an hour or two, and that's where 3D printing stepped in. When in a previous job in the medical device industry, I had like a boss of a boss, a VP who like found out I was leaving to go to a 3D printing company. He's like, I don't, he was like a mechanical engineer, very, well-educated technical guy. And he said, well, what do you even do with those things? And I feel like now after a pandemic and understanding that like that's where 3D printing lies and can be solving these like global problems, I feel like those types of questions like won't be asked anymore. We now understand how 3D printing.
Yeah, of course, and it has a huge effect on depressed economies. Like Spain during the last decade or so, we've been in a constant crisis with a lot of unemployed people, and I mean, I'm not an expert or an economist here, but one of the reasons that the everybody can understand is we had a shift from industry to services, and we sent out all the industries, and we were relying completely on globalization and things coming from China or from Eastern Europe. And of course, it has good things, scale economy and whatever costs are super cheap to get a new car or home appliance. But I mean, the richness that you are creating just with services, it really endangers the wealth of an economy. So I think that Europe has realized that having added value factories capable to produce locally, efficiently, this is a must in order to remain competitive over the coming years and challenges that may arise in this super changing scenario that we are living.
Yeah, I'm excited about the future of 3D printing. So it's good to hear that you are as well. Well, Eric, I appreciate your time and your insight into BCN, its roots, where it came from, and learning quite a bit more about IDEX and dual extrusion 3D printing and how BCN has sort of taken that mark and claimed it, put a stake in the ground around IDEX. I think you guys are doing a great job.
Thank you very much, Dave, and it's been a pleasure to be here. Thanks for having us and allowing us to share our experience and spread the word of BCN3D.
That's awesome. Thanks for your time, Eric.